So we've spent a bit of time talking about polar coordinates, rectangular coordinates, polar equations, rectangular equations. And in your notes, there were quite a few problems that said try. So this video is just going to go through and work out the solutions to those. Hopefully you've gone through and you've tried them, and you can check yourself on your answers here. So the first part of the problems, there were 3 problems that said this. Number 5 said to plot the polar coordinates -1, 3 pi over 2. And just to save a little bit of space here, I'm just going to do it in different colors. Number 6 is the point 4, -2 pi over 3. And, whoa, sorry, didn't mean that to go down on us. Let me get that back up. Technical problems, okay. And number 7 is the polar coordinates -2, -11 pi over 6. All of these are plot problems. So let's look at these to start with. The first one, we want to plot the point -1, 3 pi over 2. So our direction, our angle is 3 pi over 2. So if you start on your polar axis, so right here's our polar axis, and there's our origin, our pole, the point 0. If we go 3 pi over 2, well, up here's pi over 2, pi, 3 pi over 2. This is the terminating side right here for 3 pi over 2. Now, our R value was -1. So that means we go the opposite of our terminating side by 1 unit. So the opposite of the terminating side is up here at actually pi over 2. So instead of coming down 1 unit and being on the angle 3 pi over 2, we're going to go the opposite direction. So right here is that coordinate -1, 3 pi over 2. Okay? So that's number 5. Number 6 is the polar coordinate 4, -2 pi over 3. So our direction angle is theta equals -2 pi over 3. So starting at your polar axis, -pi over 3 would be right here. -2 pi over 3 would be right here. So here's the terminating side for -2 pi over 3. Our R value is 4. Since it's positive, we're going to go on the terminating side 4 units. So right there is the point 4 and -2 pi over 3. Okay? If it's a positive R value, it is on that terminating side. If it's a negative R value, it's in the opposite direction of the terminating side. Number 7, -2, -11 pi over 6. -11 pi over 6 is our angle. So starting at the pole, if you go clockwise 11 pi over 6, you get right here. Okay? That's your -11 pi over 6. Our R value is -2, which means we go 2 units in the opposite direction of that angle. So instead of going this way 2 units, we're going to go this way. I should have dotted it, 2 units. So right there is the point -2, -11 pi over 6. Okay? So those are your points for numbers 5, 6, and 7. All right. So we can plot polar coordinates. Let's go ahead and look at the next set of try problems. Excuse me. Numbers 10 and 11. Now, number 10 was to convert the polar coordinate 5 pi to the rectangular coordinate. So that's your XY ordered pair. So what do we know? We're given that r is 5 and our angle theta is 5 pi. Remember that we know that x is equal to r times cosine of theta. So x would be 5 times the cosine of 5 pi. Any odd whole number multiple of pi is on your unit circle on the x-axis going to the left. The cosine at any odd number times pi is going to be a -1. So we have 5 times -1, which is -5. So our x value is -5. Our y value is r times the sine of theta. So that's going to be 5 times the sine of 5 pi. If you are on the x-axis and 5 pi is on the x-axis, your y value is 0. So your sine is 0. So that's 5 times 0, which is 0. So our rectangular coordinates are -5, 0. Those rectangular coordinates would correspond to the point 5, 5 pi. Okay. Number 11 is the same type of problem. We have the polar coordinate -√3 and -2 pi over 3. And we want to convert that to the rectangular coordinates x, y. So if we look at this, again, our r value is -√3. Our angle is -2 pi over 3. And we know that x is equal to r times cosine of the angle. So that would be -√3 times the cosine of -2 pi over 3. Now, think about what we've done before. -2 pi over 3 is in quadrant 3, okay? This is in quadrant 3. Any pi over 3 angle is going to have a cosine that involves a 1/2. If we're in quadrant 3, cosine is going to be a -1/2. So we have -√3 times -1/2. So x is equal to a positive √3 over 2. Okay. We also know that y is equal to r times the sine of theta. So y is equal to -√3 times the sine of -2 pi over 3. Okay. Again, this angle is in quadrant 3. Sine is going to be negative in quadrant 3. And any pi over 3 angle is going to have a sine of √3 over 2. So we have -√3 times -√3 over 2. Our y value is a positive 3/2. Okay. So our answer for this, the rectangular coordinates, you have an x value of √3 over 2, but a y value of 3/2. Okay. So that's how you can convert from polar coordinates to rectangular coordinates. All right. Let's look at the opposite direction. What if we wanted to go rectangular to polar? Let's look at that. So rectangular to polar. So the try problems that you had for those, number 15 was -1, -1 to our polar coordinate, which is in the form r theta. So if we look at this, what do we know? We know that x is -1, and we know that y is -1. We know x and y. We don't know r, we don't know theta. So if we think about all of the things I asked you to know, think about all the things we had. We knew x was equal to r cosine theta, y was equal to r sine theta, r squared was equal to x squared plus y squared, and tangent of theta was y over x. Excuse me, I started to write that a little differently. Well, the thing is, we know x, but we don't know r and theta. Since we don't know r and theta, Neither of those are really going to help us out much, okay? But since we know x and y, these could. We know x and y. We know that r squared is equal to x squared plus y squared. So go ahead and substitute and deal with that guy. Just a second. Okay, so substitute in what we know for x and y. That means r squared is equal to -1 squared plus -1 squared. R squared is 2. And when we were doing this, we wanted to write it where we had a positive r value and we had an angle within 1 revolution of the unit circle. So I'm going to write this as r equals square root of 2. So we have our r value. Now we also know that tangent of theta is equal to our y over x. And since x is not 0, we can use this. So tangent of theta is equal to -1 over -1. Tangent of theta is 1, which means theta is equal to the inverse tangent of 1. And what's the angle? Remember, inverse tangent is defined to be between -pi/2 and pi/2, okay? What angle between -pi/2 and pi/2 has a tangent value of 1? It's pi/4. So we know our r, we know our theta. So our answer to this is square root of 2 and pi/4. Those are our polar coordinates that correspond to that rectangular coordinate of -1, -1. Okay? Go ahead and look at the next one. Number 16 says to convert -2 root 3, -2 to a polar coordinate. So we know we want something in the form r theta. We want the r to be a positive value. We want theta to be within 1 revolution. So again, we know that x is equal to -2 root 3. We know that y is equal to -2. This is in quadrant 3 because both x and y are negative. So we know we're in quadrant 3. So we know our angle theta has to be in quadrant 3 somewhere. Okay. So we know that much. But since we know x and y and we don't know r and theta, the ones that are most useful, we know that r squared is x squared plus y squared. So r squared would be equal to -2 root 3 squared plus -2 squared. That's going to be -2 squared is 4. Square root of 3 squared is 3. -2 squared is 4. So that's 12 plus 4 is 16. So r squared is 16, which means r is going to be square root of 16 is going to be 4. So we have our r value of 4. Now we need to get our theta. We know that tangent of theta is y over x. So tangent of theta is -2 over -2 root 3. I can go ahead at any point and say theta is equal to the inverse tangent of this. This would be a positive 1 over root 3 or a square root of 3 over 3. Okay, square root of 3 over 3. We were to look at that. Now, is that one of our nice values? Is there any place around the unit circle where tangent is square root of 3 over 3 or 1 over root 3? Okay, think about this. It is positive, so we're between -pi/2 and pi/2 for this part of it, okay? Inverse tangent's defined from -pi/2 to pi/2. This is actually going to give us our reference angle, okay? Remember, if theta is equal to pi/6, think about the coordinate of pi/6. That's a root 3 over 2 and a 1/2, okay? So tangent of pi/6 is y over x. That's 1 over square root of 3, or square root of 3 over 3. Pi over 6. This is one of our nice angles, pi over 6. But that's in quadrant 1, okay? That's in quadrant 1. That's here. We know that this coordinate's in quadrant 4. So our reference angle is pi over 6. If we are down here in quadrant 4 and we have a reference angle of pi over 6, we had pi, we're increasing by pi over 6. That's a 7 pi over 6. So we're actually at the point where our R value is 4 and our angle is 7 pi over 6. So we do have to be careful when we go through and look at this problem and think about what quadrant are we in? What is that angle that terminates in that quadrant? Because inverse tangent is always going to give you something in quadrant 4 and quadrant 1. So it's going to give you the reference angle and you convert from there, okay? So that was number 16. The next set had us converting equations. So numbers 20 and 21 were convert to a rectangular equation. And number 20 had the equation theta equals negative pi over 2. Rectangular equations will have x's and y's. Remember the toolbox of things we know. We know that x equals r cosine theta. We know y equals r sine theta. We know x squared plus y squared equals r squared. We know that tangent of theta is y over x, okay? Which means that theta is equal to inverse tangent of y over x. All right. Well, as we look at this guy, we think about what we have going on. We have theta equals negative pi over 2, okay? All right. We have theta equals negative pi over 2. We need to have some way to get to theta, okay? And we know theta is the inverse tangent of y over x. Inverse tangent of y over x is equal to negative pi over 2. What does that mean? That means the tangent of negative pi over 2 is equal to y over x. Okay. But let's think about this. At negative pi over 2, think about our unit circle. Negative pi over 2 is right here. The ordered pair, well, any ordered pair here is going to have 0 and a y value, a negative y value. I can't divide by 0, and x is 0 there. So actually using our inverse tangent isn't going to be helpful there because I can't divide by 0. And that's going to be the case. Okay. Now, think about this. If you know that your angle is at negative pi over 2, what's this mean? This really means anything that has a y value at negative pi over 2 is going to fit y equals some number, right? Just y equals a constant number. And actually, no, sorry, whoa. Vertical lines, sorry, I've been distracted by puppy tonight. I apologize for that. Vertical lines are always in the form x equals a number. Your y-axis is always in the form, or your y, a vertical line is y, x equals a number. Your y-axis is x equals 0. So in order for your angle theta to be negative pi over 2, this is going to have to fit x equals 0. Okay? It's the only way that's going to happen. X is 0. That's our rectangular equation. Let's look at number 21. Number 21, we have r equals 6 times the secant of theta. Up here's our toolbox. Okay. Here's our toolbox. Now we know x squared plus y squared equals r squared. We know tangent. Okay. We also know x is r times cosine and y is r times sine. Well, I don't have cosine or sine here. I could think of this as the reciprocal of secant is cosine, so that's 6 over the cosine theta. I could multiply both sides by cosine theta. So that gives me r cosine theta equals 6. Ah, look at that. R cosine theta, we know is x. That gives me x equals 6. That's also a vertical line. So both of those ended up being equations of vertical lines. Okay. So there's that example. Let's go ahead and look at a couple more. The last type of problems that I had given you some to try were to convert from rectangular to polar form. So the last two that we'll look at here. So I want to convert a rectangular equation to a polar equation. Okay. So I'm given x's and y's, and I want this in the form r equals, where I only have r and theta involved in it. Okay. So number 25, we have x is equal to y. Okay. All right. As we look at this one, so a few things that we know. X is equal to r cosine theta. Y is equal to r sine theta. I'm writing our toolbox down again. R squared is x squared plus y squared. Theta is inverse tangent of y over x, where x is not 0. That's kind of our toolbox of rules there. We're given x. We want things in terms of r and theta. We know that x is the same thing as r cosine theta. We know that y is the same thing as r sine theta. Okay. R cosine theta equals r sine theta. All right. So if we look at this, I'm going to subtract r sine theta from both sides, equals 0. I factor out an r. Okay. We get r is equal to 0 divided by cosine theta minus sine theta. Think about what x equals y, what x equal to y looks like. This is another special case. Let's think about what x equals y looks like. X equals y fits this line right here. Every x value is equal to every y value, 1, 1, 2, 2, 3, 3, etc. This is actually, if we think about a circle around this, this is actually the angle pi over 4. Okay, it's going to happen at an angle of pi over 4. Notice on pi over 4, both your x and y values are the same. So the cosine of the angle and the sine of the angle are the same. Okay. So really for this one, anything that fits x equals y is just going to be the angle theta equals pi over 4. The radius could be anything. The radius r could be any number, because no matter how far out you go, you're still going to be on the angle theta equals pi over 4 every single time on that one. So this is another one of those special cases, okay? Theta equals pi over 4. Let's look at 26. 26, we have x squared plus y squared equals 25. Well, we know that x squared plus y squared is r squared. Okay. So r squared equals 25, which means r is equal to plus or minus square root of 25. R is equal to plus or minus 5. Okay. It doesn't matter what the angle is on this one. Any angle with a radius of 5, because you can go any direction for any angle. So any angle with a radius of 5 would satisfy this. So this one, we just have r equals 5 as our equation. Lots of times we will end up with both theta and r's involved, but those are just a couple more examples that you had in your notes and in your problems to try. Try your homework. There's a bunch of homework problems for you to try in this section. Get familiar with converting between those. Make sure you know these guys right here. If you run into something that just feels weird, like this, okay, think about what this means for a minute. What do we know about x equals y? Or the problem we had a little bit ago where we knew an angle negative pi over 2. What did that tell us about what was going on? So think about those things. Otherwise, we'll use these values, okay? So try your homework, give a yell if you have a question. I'll talk to you later.